To divide two polynomials, we can use a process called synthetic division. Now, what's nice about this is it's a really cool shortcut for dividing. The downside is it does not always work. We have to make sure that what we're dividing by, called the divisor, is always in this form, where it's just x plus a number or x minus a number. As soon as you have x squared or a trinomial, something with more than two pieces in it, synthetic division will not work. But let's take a look and see how synthetic division could be used to divide something like this. So start with what you're dividing by, and what we have to make sure is we do the opposite sign of what's inside parentheses. As we've done a few times this year, we've changed the sign with the number of parentheses. So I'm going to put a 2 down instead of a -2 and draw a little half rectangle around it. Next to that, I'm going to list out all the coefficients of what I'm dividing into. A couple things I have to check for. One, I need to absolutely positively make sure that that's in descending order. So start with your highest exponent and work your way down the list. And I can see that in this one, that's the case. I have x to the third power, the first power, x to the third power, the second power, the first power, and the constant's always at the end. So it is in descending order. The second thing to check for is check to see if there's any terms that are missing. For example, if you jump right from x to the third to the x term without an x squared in there, you need to include a 0 for any terms that are missing. And if you don't, you'll absolutely be wrong. So in this case, I can see that that's also true. I'm not missing any terms. It's in descending order. So let's list out our coefficients. So first up is a 1. Leave a little space, followed by a 5, a -7, and then finally a constant of 2. Okay? Draw a line a little bit below those numbers, and we're going to start the process for synthetic division. The way this works is going to be just a series of a couple steps we repeat over and over until we're out of numbers. So you always begin by taking that first number and just dropping it straight below the line. The first number always just drops. Take the number below the line and multiply it by the number in the box. 1 times 2 is 2. Record that in the next column above the line, and then add those values together. 5 plus 2 gets you a 7. Once you write that number below the line, you repeat the process. So take 7, multiply it by the number in the box, the 2, come up with 14. Add those values together, -7 plus 14 gets you a 7, and then repeat again. So 7 times the 2 that's in the box is 14. Record that number, add those values together, and we get 16. We're out of numbers. Now, we're done with the problem, but we have one more little thing we need to do. We do need to write our answer as another polynomial. So these numbers are our coefficients in our answer. The 1 represents 1x, and you always are going to start 1 power lower than what you began with. So since we began with x to the third, our answer is going to begin with 1x squared. And if you want to see why that's the case, think of it this way. Everything's going to get divided by everything else. So at one point, we're going to be doing x to the third divided by x. Because we had x to the third, we were dividing by x to the first, and our rule is to subtract those exponents, so we've dropped by a power. So that's why I'm always 1 power lower than when I began. So the next step would be plus 7x, and then finally plus 7. Now that 16 is left over, it's not another constant. You probably remember from long division in elementary school that the number left over represents a remainder. You probably wrote this before as like remainder 16. We don't do that anymore in high school. The way we represent remainders is we say we had 16 pieces left over out of what we were originally dividing by, which was not 2. What we were originally dividing by was x minus 2. And we do need to make sure that we have some kind of sign between our constant and the remainder. So I'm going to throw a little plus sign in there. So this is going to represent my quotient. 1x squared plus 7x plus 7, and then plus the remainder, which is 16 over x minus 2. And that's how synthetic division works. If you think you've got it, why don't you go ahead and try this one on your own, pause the video and try it. Otherwise, let it play through and we'll take a look at it. So the way it starts is take what you're dividing by, as long as it's in the form of just x plus a number or x minus a number, and change the sign of what you're dividing by. So in this case, a -5 is what's going to go in the little half box. Next to that, I'm going to list my coefficients in order of what I'm dividing into. So I'm noticing this time a couple things. First of all, I'm not in order. Look, those two terms are out of order, so you absolutely must rearrange them. So this will end up being a positive 16x and then a minus 35. If you don't write them in descending order, this is not going to work. One thing I'm noticing as well, notice my exponents. I have 4, 3, and then I jump down to 1 in my constant. So I'm missing the x squared term. I must put a 0 in place for that x squared term. So when I list out my coefficients, I've got a 1 and a 4, followed by the 0, then 16, then -35. If you don't put them in that order with the 0, it absolutely will not work. Draw the line, and then here's how synthetic division works one more time. Drop that first number straight down. Take the number below the line and multiply it by the number in the box. So 1 times -5 is -5, and then add those values together. And then just keep repeating until you're done, until you're out of numbers. So -1 times -5 is +5. Add those values together and repeat. 5 times -5 is -25. 16 and -5 add up to -9. And one more time, -9 times -5 is 45. Add those values together, we end up with 10. So we haven't quite finished. We do have to interpret those numbers to be our answer. So we start with 1x, and we're always 1 power lower than where we began. So we're 1x to the third this time, minus 1x squared, plus 5x, and then -9 is the constant. That last number represents our remainder, so we say we have 10 parts left over out of what we were originally dividing by, which was x plus 5. And then don't forget that sign in between there, so throw a plus sign down there. So there's going to be my quotient with my remainder. Here would be another great time to pause the video and try another synthetic division problem on your own. Otherwise, we can go through this one together if you want to see one more example of how synthetic division works. Take what you're dividing by and change the sign, so +3. And then list out your coefficients in order, noting any that might be missing. In this case, I'm in order, and no terms are missing, so I can just list them out the way they appear. Something interesting is going to happen this time as we divide this problem. So the first number drops straight below the line. Multiply that by the number in the box. 1 times 3 is 3. Add those values together and then repeat. So 1 times 3 is another 3. -23 plus 3 is -20. -20 times 3 is -60, and this time I get a remainder of 0. And so what I've asked you at the bottom is, what does that mean? Think back to just basic numbers. If you divided something like 10 divided by 5, for example, there'd be no remainder, meaning that 5 goes evenly into 10, or we could even say that 5 is a factor of 10. And so really what we've just found, if I let's write out our answer. Remember, we're 1 power lower than where we started, so 1x squared plus 1x minus 20 without any remainder means that that must be a factor of my original polynomial. So what we're going to do in the next video is actually take a look at how we can use this idea to factor cubic polynomials, things to the third power, using synthetic division. For example, I know, this is kind of a sneak preview of what's coming up, I know that if I take my quotient x squared plus x minus 20, if I were to multiply that by what I had divided by, the x minus 3, I'd end up back with a polynomial I started with, the x to the third minus 2x squared minus 23x plus 60. So really we found a way to factor using synthetic division. In the next video we'll work on reviewing some things so we can factor this again so the thing can be factored completely. But as of right now, this is going to be my answer. And notice because my remainder was 0, I didn't need to include it. It went in evenly.